Hi, my name is Vicky Ramsey and I've been studying physics since 2006. This is episode 6 of my E&A video series. In episode 1, I talked about general relativity in relation to the calibration of atomic clocks, and how, according to general relativity via the principle of mass-energy equivalence, an atomic clock should require less energy in order to tick faster, when it is my observation that in the real world, an atomic clock requires more energy in order to tick faster, where, if I am correct in my observation, general relativity would have to be amended to state that clocks tick faster higher up within a gravity potential, and clocks tick faster in the greater gravitational field. In episode 2, I talked about how this amendment to the theory of general relativity would not require any changes to the general relativity equations, and how only 6 operations of modification in the form of axioms provides an alternative to the current interpretation of the general relativity mathematics. In episode 3, I talked about how interpreting the general relativity equations under the remit of these 6 axioms results that the universe cannot currently be expanding and must instead be contracting. I also talked about how, via these modifications, the redshift distance correlation can be reinterpreted. In episode 4, I talked about how this reinterpretation of the redshift distance correlation can provide a cause and effect explanation for the observed 5 sigma Hubble tension. And I hinted as to the notion that, under the remit of this reinterpretation, the Hubble tension could be regarded as empirical evidence with which to support a contracting universe hypothesis. In episode 5, I talked about this reinterpretation of the redshift distance correlation and the Hubble tension in relation to peculiar velocities, galactic flows, and the great attractor, and the manner by which all of these aspects relate to my proposal for a cyclic contracting bounce cosmology. I want to talk here about this cyclic contracting bounce cosmology in relation to dark energy, entropy, and the arrow of time. So, to give a bit of background, pre-1998, cosmologists had been expecting to find that the expansion of the universe would be slowing down due to the force of gravity, and eventually the expansion would grind to a halt, where the universe would then start to collapse in on itself. However, researchers were surprised to discover evidence implying that the expansion rate of the universe is faster now than it was in the past. This is thought of as being the result of the current dominance of an unknown force dubbed as dark energy. To directly quote the Nobel laureate Adam Rees, the simplest and oldest explanation for dark energy is that it is an energy density inherent to space, or a vacuum energy. Mathematically, vacuum energy is equivalent to Einstein's cosmological constant." Unquote. Okay, moving on to entropy. Entropy is a thermodynamic quantity representing the unavailability of a system's thermal energy for conversion into mechanical work, and is often interpreted as the degree of disorder or randomness in the system. The second law of thermodynamics says that entropy is always increasing with time. Point of fact, entropy is indeed very much associated with the phenomenon of time via a concept known as the arrow of time, where the arrow of time, also called time's arrow, is positing the one-way direction or asymmetry of time. The concept was developed in 1927 by the British astrophysicist Arthur Eddington and is an unsolved general physics question. If you are unfamiliar with these ideas, or even if you are familiar, Sean Carroll's presentation for the Long Now Foundation is a very good and extremely accessible video, where Sean's discourse on the arrow of time and entropy is entirely relevant as a precursor to this discussion. I've left a link to this Long Now Foundation video in the notes. Within his presentation, Sean refers to the facts that it is actually unsolved problems in physics as to why the universe had such low entropy in the past, and as to why entropy increasing results in the distinction between past and future, and as to why entropy increasing results in the second law of thermodynamics. What I wish to discuss here is my modification of general relativity with regards to dark energy, entropy, and the arrow of time in relation to my proposal for a cyclic contracting bounce cosmology. So, according to the Big Bang theory, the universe was in a uniform, high-density state at its very early stages, otherwise known as the universe's initial conditions. And this high-density state of hot gas was pretty near to thermodynamic equilibrium. In systems where gravitation plays a major role, thermodynamic equilibrium is considered to be a state of minimum or low entropy due to the negative heat capacity of such systems, where negative heat capacity is the same concept as stating black holes as becoming colder as they get bigger. However, stating a gravitational system's thermodynamic equilibrium as low entropy is contrary to non-gravitational systems where thermodynamic equilibrium is considered to be a state of maximum entropy. And so, it is with this notion in mind where thermodynamic equilibrium can be considered, dependent on the circumstance, as being both a state of minimum entropy and a state of maximum entropy, that I will begin to outline the notion of initial conditions and the evolution of entropy and the arrow of time within my proposed cyclic contracting bounce cosmology. So, in his video, Sean Carroll makes an analogy for entropy using the states of cream and coffee, where the coffee by itself is being considered as a low entropy state. As the cream is added and it mixes with the coffee, entropy is increased. And when the cream and coffee are fully mixed, entropy is at its highest. He also depicts a glass of coffee with the cream floating on top of the coffee. For my purposes here, let's call this arrangement the initial conditions, where the coffee and the cream are together in the glass but are not mixed with each other at all. In this configuration, it seems to me as if one could choose to view the coffee and the cream as each having their own phenomena of entropy, where if one then mixes this configuration, the entropy of the coffee state and the entropy of the cream state both increase because their original configurations within the space of the glass are becoming more disordered until both the coffee and the cream reach their maximum entropies when they are fully mixed. However, we could instead choose to state this fully mixed configuration of these separate entities, the coffee and the cream as being the initial conditions, and let lactic acidity do its work where over time the cream will curdle into lumps and will eventually completely separate from the coffee, either floating to the top of the glass or sinking to the bottom, where we could choose to view the process of the coffee and the cream separating as being an increase in the entropy of the coffee and an increase in the entropy of the cream, because the maximally ordered configuration of the coffee and the cream being fully mixed within the space of the glass has become disordered. So, before we get too embroiled in the actualities of coffee and cream details, let's leave these considerations as such in this simplistic form as an analogy, whereas I can now start applying these viewpoints to the structure of my proposed cyclic contracting bounce cosmology. But first, a quick recap. Within my modification of the interpretation of the general relativity mathematics, I have suggested that there are not one, but two dimensions of time that occur separately from each other, but concurrently to each other. One for mass that we observe as being the timing of clocks, where clocks tick faster higher up within the gravity potential and clocks tick faster in the greater gravitational field, and the other being a hidden time dimension that is inherent to space itself. Hidden because the timing in space cannot be observed directly and is only observed via its time dilation effects, where, due to an anisotropic distribution of energy in space that reduces proportionally to the inverse square law with distance from the gravitational mass, the axiom plus energy equals shorter seconds means that the rates of time in space get slower with distance from the gravitational mass. where, as a result of the time dilation effects of these separate time dimensions, cause and effect mechanics are defined for how gravity does what gravity does. So, going back to the cream and coffee analogy, as a consequence of considering the possibility of two separate time dimensions, one for mass and one for space, I am proposing that it might be useful to view mass and space as also having separate entropy phenomena. But let's first examine the notion of initial conditions. In episode 5, I explained how this cyclic contracting bounce cosmology works, but to recap in brief, let the universe contract at an acceleration equal to that of the dark energy observation. All the mass and the energy of the universe is then destined to converge into black holes that will eventually merge into a singular massive black hole with all of the universe's matter and energy inside. Due to having no balancing gravitational counterpart, this singular black hole, comprising of all the universe's energy and matter, will immediately transform into a white hole, exploding all of its content via superluminal jets, and will consequently empty itself out of existence, causing what can be thought of as an alternative type of inflation period that results in an almost uniform sea of particles and energy, and this almost uniform sea of particles and energy, due to the slightly anisotropic nature of the distribution, initiates into an extremely slow contraction process that proceeds at a snail's pace acceleration, during which the universe evolves from an almost uniform sea of particles and energy into the clump complexity of galaxies, galaxy clusters, and open spaces that we observe today, where this process will repeat itself over and over again as per a cyclic cosmology. So, as per the coffee and cream analogy, with regards to initial conditions, there is a choice of configurations. The black hole stroke white hole stage of the universe's cycle could be thought of as the initial conditions, or the almost uniform sea of particles and energy could be thought of as being the initial conditions, where again, as per the coffee and cream analogy, and also the notion that, dependent on the system, thermodynamic equilibrium can be considered both as low or minimum entropy and as high or maximum entropy. Within this structure of a cyclic bounce cosmology, there are also choices as to how one might define the low entropy state. The low entropy state could be the black hole stroke white hole configuration, or it could be the almost uniform sea of particles stroke energy. However, if we decide to view mass and space as having separate entropy phenomena, then within the sea of particles stroke energy configuration, mass could be considered as being either in a low entropy ordered state or as being in a high entropy disordered state, where exactly the same consideration could be made for the entropy state of space. And, at the other end of the spectrum, regarding the black hole stroke white hole consideration, we have a similar scenario. If mass has been considered highly ordered as a sea of particles stroke energy, then in the black hole stroke white hole configuration, mass is maximally disordered, or vice versa. And if space has been considered as highly ordered when proliferated with a sea of particles stroke energy, then when mass is conglomerated into the black hole stroke white hole configuration, space is maximally disordered, or vice versa. In this fashion, it would appear that when defining a highly ordered state, it is only the matter of one's taste that is relevant. But let's now go back to the notion of two separate time dimensions. In the black hole stroke white hole configuration, the rate of time for mass will be at its fastest, where the rate of time for space will be reducing proportional to the inverse square law with distance from the black hole stroke white hole configuration. However, in the almost uniform sea of particles stroke energy, the rate of time for mass will be almost uniform, and the rate of time for space will also be almost uniform. So, bearing this in mind, it makes a lot more sense to choose the sea of particles stroke energy configuration as being the initial conditions. Yet, since the rate of time for mass, for the greater part, will tend to be increasing as the clumping process evolves, and the rate of time for space, for the greater part, will tend to be decreasing as tracts of space become devoid of particles, one could choose to state the sea of particle stroke energy configuration as being low entropy for mass because the rates of time will be increasing for mass, and being high entropy for space because the rates of time will be decreasing for space, where, as the universe evolves from the sea of particle stroke energy into the black hole stroke white hole configuration, the entropy is increasing for mass and decreasing for space. And if we examine the other end of the scenario, where the black hole stroke white hole configuration explodes into a sea of particle stroke energy, entropy will then be decreasing for mass and increasing for space. However, let's not get set in stone just yet. Let's examine the arrow of time. So, looking at the notion that time dilation affects the rates of time for clocks, and my proposal that time dilation also affects the rates of time within a time dimension inherent to space itself, one might view this situation as being a case of different coordinates within the universe being differently time located, i.e. either being placed further into some definition of the future, or as lagging behind within some definition of the past, where the notion of the present or the concept of a moment in time defined as being now is not universally shared. However, I can imagine another option where we regard these time dimensions of mass and space and their time dilation properties as being inherent with timing rather than the passing of time, and that the mechanism by which we can make a distinction between this timing and the passing of time exists within the phenomenon of dark energy. Earlier on, in describing how my proposal for a cyclic contracting bounce cosmology works, I said, let the universe contract at an acceleration equal to that of the dark energy observation. Okay, so the magnitude of the dark energy acceleration can be calculated as r divided by c squared, where r is the radius of the observable universe and c is the speed of light. For the record, I just quoted Lisa Molin's book The Trouble with Physics from the chapter Surprises from the Real World. R divided by c squared is a very slow acceleration indeed, and in the expanding universe hypothesis, it is yet another unsolved problem in physics as to the cause and effect mechanics of how this acceleration occurs. What I am proposing is that as the universe contracts, the energy density of the universe increases, where, via the axiom plus energy equals shorter seconds, the rates of the many different timings for all of the universe's mass and all of the universe's space are marginally increased. In fact, all of these timings throughout the entire universe will be subject to an acceleration equal to that of r divided by c squared. Okay, so regarding the equation r divided by c squared, things do get a little bit more complex here. In consideration that the speed of light is a distance held relative to the length of a second, and the fact that we are going to say that all observers will measure the speed of light as being 299,792,458 meters per second, if I was to ask each observer within their differing gravity potential locations throughout the universe to turn on a photon emitter that emits one photon, and to measure the distance that photon travelled within the timescale of 1 second, and I then asked each observer to divide that distance into 299,792,458 units in order to create for me a measuring rod that is the length of 1 meter, because the observers' clocks are all ticking with different length seconds, I would find that these measuring rods are all of differing lengths. The observer whose clock was ticking with shorter seconds will have given me a rod that is shorter than the rod of the observer whose clock was ticking with longer seconds. To say so, making these considerations where the speed of light is held relative to variable length seconds does get very interesting indeed. And I will at some point devote an entire episode to the subject, but for the purposes of this video, where r has been defined as the radius of the observable universe, and the radius of the observable universe is currently defined by the speed of light held relative to the current interpretation of the age of the expanding universe, where the equation r divided by c squared results in an acceleration that is in agreement with observation, it is of no matter that I am changing the expanding interpretation of that observation, because as long as I keep tabs on the inverted nature of the consideration, as a mathematical function where each observer is measuring r as being a different magnitude of radius, because each differing radius has been defined as proportional to the length of the second that the observer in that location holds the speed of light relative to, the calculation r divided by c squared will result in the same magnitude of acceleration for every observer at every and any location of the universe. And this is an important factor, because what we are looking at with this consideration is an updating to the timing of all clocks universally, with a constant decrease in the length of a second for the timings of both the mass time dimension and the space-time dimension, where it is this universal acceleration of the rates of timing everywhere that are the cause and effect mechanics of the contraction itself. The contraction causes the universal rates of timing throughout to increase, and the rates of the universal timing throughout increasing causes the universe to contract. Now, to say so, this notion really is exceedingly powerful and far-reaching. Not only does it allow for the concept of a universally shared moment of time that we can call now, which lends itself to entirely negating the idea that time dilations are placing locations of the universe further into some definition of the future, or lagging behind within some definition of the past, where we can then accept that the timings for mass are simply energy-related effects that cause atoms to jiggle faster or slower, and that the timings for space cause the momentum of objects of mass moving through space to be increased or decreased, where we can now state the effect of this dark energy acceleration that is constantly increasing the timings of all mass equally, and the timings inherent to all space equally, throughout universally, as actually being the passing of time, or in other words, being the arrow of time. Okay, so going back to entropy. When viewing the arrow of time as I have just described, this acceleration in the rates of time for mass and for space can then be thought of as entropy increasing, where it is interesting to consider that within this description of a contracting bounce cosmology, it becomes obvious that as the energy density of the universe is constantly increasing via the contraction, the restrictive aspects currently attached to the second law of thermodynamics may require re-evaluation. And, as an extension to the notion of the arrow of time and entropy increasing, carried over through further evolutions of this bounce cosmology, it does become necessary to also partially re-evaluate the first law of thermodynamics. I will be discussing these re-evaluations in relation to a more detailed description of how gravity does what gravity does in my next episode. But meanwhile, I have left links to all of the aspects I have discussed here today in the video notes. Thanks for watching.